if you've been tuning in to these videos up to this point, you probably know what I'm going to tell you. Put your name on the paper. Put your class number on there. It's very helpful. You want to get credit for all this hard work, right? Unit 2, Module 2, Session 5, Multiplication Strategies. If you look at number 1, just by itself, man, I've got a lot of zeros going on. Well, that's what we've been learning a lot about in Module 2. So let's apply what we know about zeros, which is if I take, any number, right, just any number, right, times 10, so any number, I should probably write it that way. If I take any number times 10, my answer is going to be that number with a 0 on the end. Okay? So if I take a 3 times 10, my answer is going to be 3 with a 0 on the end. Okay? That is one of the strategies that we are learning. And that works with any number of zeros. If it's 100, we add 2 zeros. So this answer would be 300. Okay? So just a little bit of review. Okay? Let's dig in. I'm going to see if I can get a little bit closer as we go through these problems. Okay? 10 times 3 is 30. Now, but then when I take 3 times 20, there's different strategies we could use. 10 is the same as, 20 is the same as 10 times 2. Well, 30 times 2 would be 60. We could answer it that way, but we want to use the strategies that we've been talking about. 10 times 3 is the same as taking 3 times the first number, which is 3, and adding the 0. Well, if I do the same strategy here, 3 times 2 is 6. I'm going to add this 0 to the end of the number. I'm not adding 0. I'm not going plus 0. No. I'm just taking the 0 and putting it on the end. Okay? If I apply that strategy again, take this number times your first number. 3 times 3 is 9. Take that 0 and place it on the end. Your answer is 90. You could take 30 and count it 3 times, right? You could add 30 plus 30 plus 30, still get 90. That's a lot of mathing when we can just use our strategy that we have here, okay? Ooh, no, my goodness. This is going to be interesting. Some number times 3 is 120. If I want to work this backwards, right, this gives you no answer. This gives you no beginning, okay? If I say 3 times what is 12, and let's forget about this 0 for a minute. 3 times what is 12? Well, 3 times 4 is 12. Put that 0 in there. See how I did that? And the answer is correct. I could double check, right? I could say 3 times 4 is what? 12. Add the 0 to the end, 120. Your answer is still the same. So sometimes you have to just remove the 0 from the answer to figure it out. Okay? I'm going to let you go through the remainder of these problems. Right? You can take 3 times 5, put your answer down here and place the 0 at the end. 3 times 6, place it down here, add your 0 to the end. 3 times 7, put it here, place the 0 on the end, and pause this video if you need to. Okay? On the next line, they're going to take one of our products out, okay? Actually, that's the product. They're going to take our factor out that we're multiplying the number by. 80 times something equals 240. Well, if I just thought to myself, 8 times what is 24? Let's take these zeros out for a second. 8 times what is 24? 8 times 3 is 24. So 0 times 3 is 240. You can double check your answer by taking 3 times 8, that's 24, place your 0 on the end. Aha! That was correct. Those are a little bit harder, but they can be made a little easier if you think about the numbers without the zeros. The zeros can be overwhelming. Get rid of them! And then put them back when you're done, okay? I'm going to let you do these problems on your own as well. This one is the same as these up here. Same process, different numbers, okay? Multiply the firsts, place the 0 at the end. Now, what did we talk about up here when we were talking about our zeros strategy? We said that the number of zeros matters. 3 times 1 is what? 3. How many zeros do you see? 2. You put them back on. All right? The strategy doesn't change if you have 3 zeros or 4 zeros. You just place however many zeros on the end of the number. Okay? I'm going to let you do these two on your own. Some number times 3 is 300,000. Well, let's start by asking ourselves, 3 times what is 3? 3 times 1 is 3. How many zeros? 1, 2, 3, 4, 5. Put them up. 1, 2, 3, 4, 5. 10,000 times 3 is 300,000. Okay? I am going to let you do this last one on your own. Okay? Pause any point in time that you need to, okay? Explain any strategies you use to make it easier to figure out the answers to the problems above. We used at least 2. Any number times 10 is the number with a 0 placed on the end. Okay? You could repeat all of this just by saying, you could replace everything except that, and you would write 2 zeros. Right? You could do 1,000, and you would say 3 zeros. Right? As this, 1,000. So as that number increases, the number of zeros you add to the end increases. So that's a series of strategies that we used. Okay? And if you used any extras, you can put them in there as well. All right? Solving these problems will seem a little trickier, but the goal is to do these in your head. There's only single digits on the bottom. Your goal is going to be to take the number on the bottom times the first digit and then bring the zeros, one or more of them, down below. 4 times 1 is 4. Bring the 0 to the end. Answer is 40. This might get tricky depending on whether you have a number that calculates to a multiple of 10. And I'm looking through your examples right now, and I'm having trouble finding any. Okay, down here. Here's a perfect example. 8 times 5 is 40. Am I done? Not really. You have 1 0 left to bring down. The error that I see some people make is they say, well, I already have a 0. Why would I bring that down? Well, this 0 was not brought down. 5 times 8 is 40, and then you bring the 0 down. So as you're going through here, if you ever do a calculation where the first product is a multiple of 10, in other words, it ends with a 0, 10, 20, 30, 40, 50, 60, 70, 80, make sure you don't accidentally miss your last step. If it's 1 0, bring down 1 0. If it's 2 zeros, bring down 2 zeros, okay? And I'm going to let you do these on your own. Pause if you need to. Back page. Look at the rectangle below. If the area is 240 square centimeters and one side is 12 centimeters, what is the length of the other side? It would like you to show your work and write your answer on the line provided down below. Okay? The area. What is area? Area is when you multiply the dimensions. So you could say area is maybe the height times the width, if you want to think of it. How tall it is times how wide it is. Well, we know how tall it is. It's 12. And we know our area. So our area is 240. Let's see, maybe I'll do our work over here. The area is 240. And the area is the height times the width. We know the height. The height is 12 times some number, which in this case is an x, okay? 12 times something is 240. If we set this up just like before, it looked like this. Do you remember? Something times 12 is 240. If you'd rather have the question mark on the bottom, you could say 12 times some number is 240, right? We'll see. One of these might be easier. Well, hold on a sec. 12 and 24 are pretty friendly numbers, aren't they? What if I get rid of this 0 for a second? 12 times what is 24? Well, 12 times 2 is 24. Put your 0 back on. The answer is 20 times 12 is 240. So if this is 12, what is this? 20. We know that because 20 times 12 is 240. And if you thought to yourself, well, I don't know if that's exactly true, check your math. 20 and 12. 12 times 2 is 24. Place your 0 on the end. Yeah, sure is. 240 square centimeters. So the x, this missing number, the width of our rectangle, is 20. Now what's the units? Area is measured in square centimeters, but height and width is just going to be plain old centimeters. Don't forget your units! Okay. Sonia measured the cover of the library book she was reading. The length was 10. Oh gosh, I like to draw a little bit. So this is my poor drawing of a book. The length was 10, so we have 10 inches. And the width was 5 inches. Kind of a small book, but that's okay. Which equation below represents how to find the area of her book cover? So we know the dimensions. We just said that area is height times width. Do we know the height and the width? We know the height and the width. To find area, we multiply. One of those is the area, and I'm going to let you select the one that is multiplication of the dimensions. Fill in the ratio table. Ooh, goodness, we got to do lots of ratio tables in this module. Looks like we're counting by uh-ohs. 1 is 31. So it looks like we're skip counting by 31s. 2 would be double of that, wouldn't it? Which would be 62. How do I know that? I doubled the 30 and I doubled the 1. 62. 20. Am I gonna go 31 plus 31 plus 31 plus 31 plus 31 plus 31? Am I gonna do that 20 times? No. What number have we been working a lot with so far? 20. Oops, and hold on 1 second. My document camera is gonna shut off if I don't hit cancel on my screen. Give me 1 second. Okay. What was I saying? I've already forgotten. Oh yeah. We do not want to just add 31 20 times. Look at this. 2 and 20. How are they related? 20 is the same as 2 times 10. So this number has to be this number times 10. What is 62 times 10? Well, we know the rule is that if you take any number times 10, all you do is take the number and add a what? A 0 to the end. So this is 620. Okay, this one, slightly more challenging. However, I think we can get there if we just fill in one missing step. 31 is the first multiple. 31 times 2 is 62. 31 times 3 is 93. Does that look familiar? Does that look familiar? Yes, it absolutely is. So that means these are out of order. In my brain, I was thinking 3, 6, 9. And then I thought 1, 2, 3. So I got there kind of step by step, but that's okay. Now we need to know this, because if 3 times 31 is 93, 30 times 31 has got to be something pretty similar to that. How does 3 and 30 compare? 30 is the same as 3 times what? 3 times 10. So that means this has to be 93 times 10. And we know if we take any number times 10, it's just the number with a 0 added to the end. 10 times 31. That's going to be the number with a 0 on the end. Now, here's a little tricky one. I don't know about this one, but I bet we can figure this out. 5, how does 5 compare to 10? Well, 5 is exactly half of 10. What's exactly half of 310? Well, half of 300 is 150. Half of 10 is 5. So my answer is 155. Last but not least, 1,550. Oh, goodness. That's basically this number plus a what? A 0, which means this number here is going to be the same number with a 0. This can be a little tricky when you're looking for patterns. However, I think you can get there if you give yourself a lot of patience. I kind of wish this would have been in order. However, I'm glad they put the 2 and the 20 next to each other, the 3 and the 30, and then the 10, 5, and 50. It is helpful to have them grouped up. Last but not least, these challenge questions are going to really melt your mind if you let them. 9 times 9 is 81. And then add your 2 zeros to the end. Okay? I did it pretty fast, but nothing has changed. Just the problems are a little bit more difficult. Okay? 12 times 4 is 48, with 2 zeros added to the end. I'm going to let you do the remainder of those on your own. Do your best, okay? As usual, ask a trusted adult for help. Ask your teacher. We love questions if you need us, okay? Thank you.